Hi everybody, this is Parthabasu. This is my fifth video on YouTube. Today is 26 March 2026. Today I am to discuss technical thing like basic equipment strategy and preventive maintenance for high voltage induction machine. So everybody knows that motors are the most widely used equipment in the world. So motors, AC induction motors are in use for more than 100 years, actually 150 years. So although most of the motors used in the world are low voltage motor, but as the industry is getting bigger and bigger to take the cost efficiency, the motor size also getting bigger and bigger. Like if you see large industry like oil and gas, petrochemical plant, cement plant, large other paper industry, all of them are using high voltage motor because the capacity is high to have the cost of economics. So the high voltage motor use has been growing exponentially. Of course, high voltage motor is slightly complex in design compared to low voltage motor. So maintenance and equipment strategy is also different. Among the high voltage motor, there are like the three basic type of motor: AC induction motor, AC synchronous machine, and the DC motor. DC motors are not used much nowadays after the inverter become very popular. Earlier, the DC motors are heavily used where high starting torque are required because DC motor has got a high starting torque compared to induction machine. Now because of VFD it is no more required. So even if you see in the crane etc., nowadays they use AC motor with a inverter supply. DC motors are still used. But today we will mainly discuss the AC induction machine. Synchronous machines are very limited use, limited application, very specific application we can discuss another day actually. So due to long usage history, the motor design and construction is quite simple nowadays. There are hundreds of companies in the world manufacture high voltage motors. Of course, not all of them are good. The quality spread is very wide. You get very good motor in one end of the spectrum, and you get not so good motor in the other end of the spectrum. So of course, the reputed vendor is slightly more costlier, but most of the time it is better to pay the money than to have a peace of mind. But even if I consider the big names like ABB, Siemens, Toshiba, Mitsubishi, and American manufacturer, the American Motors, what is that? This is a Brazilian company, but even if you take all these motors, WEG is a good vendor. In India there is a BHEL, Siemens is there also. So among these vendor also, there are some motors are last longer and some motors last longer. And to some extent, I will not always blame the vendor. Actually, sometimes we do not specify correctly the motor. That is one of the issue. So before we even do the strategy, it is better to know how to specify a motor a little bit for the people in the. So normally when you do a new project, Dustwood project, of course the consultant will issue the motor data sheet and hopefully they buy a good motor. But even for replacement motor, those who are working the plant, it is better to know some amount of key design features. For replacement motor, obviously one has to use the existing data sheet. It's very important because existing data sheet is important for many reasons. Power voltage, frame size is very important, otherwise motor will not fit properly. And in addition, the bearing type, enclosure type, cooling design, directional rotation, location of cable entry, these are also important. The second most important thing is the high quality end winding lapping process. This is mainly manual. So this is of course depends on the vendor. We cannot specify how to do it. But if you buy a critical motor, you should discuss this with the manufacturer. What is the end winding lapping process? So you know the motor design, the slot Some vendor provide additional slot insulation, some vendor do not provide because the motor winding itself has a insulation. So if you buy a critical motor, because this slot insulation is being avoided nowadays to reduce the cost, but if you really buy a critical motor, you might try to add this in the specification. VPI process, everybody know VPI is very good, etc. So you have to be careful. VPI is a vacuum pressure impregnation. So some people do only vacuum, the cheaper vendor. So you have to be careful about vacuum pressure impregnation. Okay. So so US standard is there, and also there is a the US standard has got a sealed winding requirement. They actually ask for immersion test. After the VPI, motor will be immersed in the water to check that. So that is of course possible for lower frame size motor. For large frame size is not possible, but one can do a water spray test. If somebody wants to be 100% sure about the sealed winding, we can specify, or you can specify the spray test or the water immersion test. So many times electrical design is one thing. During my transformer design, I explained that mechanical design is very, very important. The mechanical design is mainly the cooling duct, fan, and air direction. So of course this will be done by vendor, but during design one should look into it. And what type of cooling? There are many different type of cooling available. TFC, TEWAC, which is water cooled, TEAC, which is air to air exchangers. So obviously in America they use the WP2 motor. Of course WP2 motor is much cheaper. But nowadays I will suggest no point spending so much money and then not to specify the TFC motor. So it is better to, let's adjust my chair. It is better to specify TFC or TEAC motor or TAWC motor, because WPT motor, unless it's a very clean environment, is no point using WPT motor. Quality of cold lamination is very important. Of course, we do not see that, but you will be surprised. I have seen vendors, the cheaper vendors, they use one side lamination, because if you put two lamination, if one side is laminated, is insulated, but if that lamination is gone, the motor will fail soon because it will be hot spot. So you have to be careful about that. One should ask this question. Then the rotor design, like nowadays, to reduce the cost, many vendors started using aluminum rotor bar. So nothing wrong with that, because low voltage motor has aluminum rotor bar, but high voltage motor, copper rotor bar is always better. Aluminum rotor bar can be used. I will say that for less than 500 kilowatt motor, we can accept aluminum rotor bar. But one has to be careful. It should not be VFD driven motor, or it should not be frequently started motor, and it should not be two-pole motor. So if it is not a two-pole machine, if it is not a VFD driven machine, and if it is not a frequently started machine, then aluminum rotor can be accepted to reduce the cost up to say 500 or 750 kilowatt. Just ballpark figure actually. But if the motor is, as you know, the rotor get heated up at the time of start. If it is a frequently started motor, it is not advisable to have a aluminum rotor. The bearing, the rotor bar end winding, how the rotor bar ending is done, that is also critical. So there are two methods. One is the brazing, one is the induction heating. Both of them are good, but obviously induction heating method is slightly better, than brazing. And bearing, of course, bearing itself is a big subject. But for high voltage motor, there are 3 or 4 types of bearing possible. One is anti-friction bearing. Anti-friction bearing also have different design, like a roller bearing, thrust bearing, etc. That vendor will decide, depends upon your driven equipment. But obviously the slip bearing, or what we call a plain bearing, is much better, because technically its life is infinite if you maintain the oil inside actually. So among the slip bearing, there are two types. One is self bath type, which is the motor itself has the slinger, and the motor is cooled by the self bath type, and one is the force cooling type. Force cooling type is required for motor itself. Both types are pretty good, and there is not much difference between self bath type and force cooling type. Only difference in the maintenance. But when you use the force cooling type, if the driven equipment already have a force cooling, and if the oil type is similar, like most of the motor vendor will tell you, I need on a particular oil type like VG32 or VG46. If the driven equipment also VG32 and VG46, it is no brainer. There should be force cooling. We combine the oil for both. If the driven equipment oil is different, then we take a judgment call actually. But as I say, the slip bearing self bath type is perfectly okay. It will last the motor's lifetime if somebody do the proper maintenance, which is 30-40 years. Okay, we do not have control on the vendor internal design for sure, but in my opinion, during motor purchase, the user should take some interest so that you know what you are getting actually. Okay, so if you see all over the industry, there's a lot of data collection has been done. So if you see the failure data actually, the failure data is mostly stator winding failure is approximately 40%. If you take a total motor failure, the 40% of the motor failure happen from the stator winding failure, and another 40 to 45% happen from the bearing failures. So these two are critical. Rotor failure may be 5%, and other failure like terminal box failure, etc., enclosure failure, terminal box failure, core failure, which is very rare, all total may be 10 to 15%. So that is the ballpark figure. So basically 80 to 90% failure, 80 to 85% failure will be either stator winding or the ball bearing, or the bearing, sorry. So basically we have to take care of this. Okay. So main degradation, so let's discuss the stator winding first. What is the main degradation of the stator winding? Over the year, the insulation deteriorates from electrical stress, partial discharge at the slot or slot endpoints, slot movement because of the electromagnetic force, dirt and oil accumulation in the overhang area. So these are the main failure mechanism basically. So you degrade slowly. Partial discharge, of course, everybody understands there is a small damage, inherent damage from the beginning, and then slowly it become a tree and it fail. But the slot area, if the slot area is not tight, if the winding is moving, that also start partial discharge. Electric stress and is another thing, it will fail. So there are many tools nowadays, online partial discharge measurement or the regular offline test like polarization index, tan delta, partial discharge with applied test voltage could indicate stator winding health. Because the P2F, the finding of the partial discharge to actual failure could be very long. It could be anything between 2 to 5 years. So this is always suggested that when the motor is shut down, during turnaround, or at least every 5 years, for high voltage motor, this test should be done. If there is no online partial discharge equipment facility, it should be offline test. The most useful offline test is the tan delta test. If we do tan delta, we know approximately the motor health. Very good test, tan delta. Polarization index is of course like a mega test, 10 minutes by 1 minute. And partial discharge test can be done offline. The vendor has tools to apply test voltage. This give a fairly good idea how long will be the motor life. ABB came up with a test called LEAP test, LEAP. That give a very comprehensive end of life data for the motor. It's a bit expensive, but can be done for the critical machine. Broken rotor bar is very, very rare. If happens, it will have high vibration, especially at the time of starting. Also the current signature analysis can be done with a CT. You can find the rotor bar is broken, but it's very rare. If the vibration is high during start, you know the rotor bar may be failing. If 1 or 2 rotor bar fail, doesn't really affect the motor operation, it can run. The bearing is the most important thing. Anti-friction bearing, everybody knows you have to grease, lubricate. So motor vendor will tell you normally once in 6 months or once in a year, depends upon how big is the bearing. So the lubrication method is very, very important. Many people say, okay, I lubricate, still it fails. So the most important for grease lubricated bearing is that the lubrication must be done when the motor is running. It's very, very important. And there will be grease egress point, the spent grease must come out. So then sometimes the vendor put a lever, you pull the lever, the spent grease will come out while greasing. So what is grease? If you see grease, basically the lubricating oil in the grease is only 10 to 15%. The base is basically a wax. So what happens, the grease is, when the motor runs, it becomes, the lubricating is, thing is lubricating the oil. So lubricating oil properties goes down, and which is only 10 to 15%. So over time, so grease will, this lubricating quality will deteriorate. So as a minimum once a year, some vendors suggest twice a year. It depends upon the vertical motor, vendor will suggest every 3 months. The vertical motor bearings are working harder. Also 2-pole machine, sometimes the vendor say every 6 months, because 2-pole machine is working harder. So follow the vendor recommendation, but please remember that the greasing should be done when the motor is running, and the old grease must be seen coming out. How much to grease? You should see the bearing specification, how much is the total grease initially. It should be at least 20 to 25% of the total grease. Let us say initial grease, the vendor says the bearing type is like this, so you can say how much grease will be there. Say, let's say 250 gram. So the new grease, when you pump, it should be 50 to 60 gram. How to know it is 50 to 60 gram? That is, of course, by experience. When you take a grease gun and give a stroke, so basically one stroke maybe 1 gram. So 25 stroke 25 gram, this is like a ballpark figure. But once you do the greasing, you see the grease egress must be open, because over greasing is dangerous, because if the grease cannot go out, the old grease, it will go to the motor, because the bearing seal of course is there, but it's not it cannot stop the grease. It might, it's like a lip seal, it might puncture the seal and go into the motor. Then the motor winding will get bad and heat it up and it will fail. So one has to remember, it's very important. For slip bearing, it is very easy. Slip bearing, technically, it doesn't touch when the motor is rotating. The oil flame lifts it up a little bit. So technically, the slip bearing inside babbitt life is infinite. Okay, but nothing is infinite, because oil quality could be bad. And every time you start and stop the motor sits down on the babbitt and it lifts up. So during this sitting down and lifting up, very minor particles can be taken out from the babbitt, because babbitt is a soft material. So that's why a regular the maintenance is required. For forced lubrication, what happens? Forced lubrication, because the oil is continuously circulating and the oil test is done from the oil tank and the oil can be changed, it's very easy. So for forced lubricating is very easy. The forced lubrication system normally with a compressor or big pumps. So machinery guy will take the oil sample from the oil tank. If the oil is bad, they will replace the oil. One has to say the flow is correct. So there should be a flow meter and temperature is good, so flow is good. If it is a self-bath type, then it is very essential that oil must be changed once in 2 years. It's very, very important. And once you change the oil, the old oil should be pushed through a filter paper. And people should see that, whether maintenance people should see if there is a metal particle can be seen in the filter paper. If there's a metal particle in the filter paper, then we know that the babbitt may be, it is coming from the babbitt. Then the next time around there should be inspection. If the babbitt is bad, one can redo the babbitt by machining it. Okay, so it's very important. So even the oil could have some impurities. So if it is a forced cool type, it is managed by the machinery people, because combined with the compressor. If it is self-bath type, oil must be changed every 2 years. Yeah, that is the normal guideline. and then one can have a long motor life. Terminal box, every terminal one should open and clean. Enclosure, terminal box, these are the terminal activity. But these are the main things. So basically, stator winding, you check only you cannot check stress when the motor is running. So if there's online partial discharge test, you do that. But if there is no online partial discharge available, you do offline test. Basically, tan delta, polarization index, and the applied voltage partial discharge test. Tan delta, if it is up to 1-2% is acceptable. Moment the tan delta is more than 5%, you know the motor insulation is deteriorated. You plan for the rewinding at a certain date. Anything more than 7-8%, motor is going to fail in no time. Okay. Polarization factor, all the standards give a very clear indication. Basically, so standards say that polarization index should be between 2 to 5. Less than 2, motor is wet. More than 5-6, motor winding is too dry, so it can be brittle. So a lot of people ask me, what do you think the motor life? Well, every vendor has said many things. My motor life is this, my motor life is that. I work 40 years in industry, so obviously I see a lot of motor installed and failed, or installed and running for 30 years, installed and running for 25 years. So I can say, if we do a proper operation and maintenance care, what is proper operation? Proper operation means your cooling system is good, motor is not loaded more than 90% of its loading, 90-95. Temperatures are within limit. If the motor is temperature, the normal motor installation is class F for high voltage motor, temperature is limited to B, which is 120 degrees Celsius, actually 130, but you factor 10 degree for hot spot. So if the motor is running 100 to 110 degrees Celsius, not more than that, is a class F insulation limited to B. The motor is running and the stator winding temperature is another, this is the stator winding temperature. If the bearing temperature is less than 80-90 degrees Celsius, normally that should be the bearing temperature for an oil cooled machine. Bearing, if it is a anti-friction, then normally there is no thermometer or bearing temperature, but you can use a gun, temperature gun. At least the dry vane can be seen. Non-dry vane is difficult to use the temperature gun. So if you see the bearing temperature goes beyond 90 degrees Celsius, something wrong with your bearing cooling system for sure actually. So if we consider all these things, then we can, and of course the motor has to be serviced. I will come back to that later. I can safely say that I have seen personally, it's a good design motor, reputed vendor. I don't know to name which vendors. I already named a few vendors. So if you proper operation, proper maintenance, a 10 kV, 11 kV, 13.5 kV motor will easily last between 20 to 25 years. I have seen motor 25 years, 30 years, no issue. A 6 kV or 6.6 kV motor will last between 25 to 30 years. A 3 kV or 3.3 kV and 4.16 kV motor will last between 30 to 35 years. It's easy. I have, as I say, I have seen many motors install and work 30-35 years, and from that I jot down what are the, and some motor did not last. So I jot down a few points which to be done, then I can get this kind of motor life, like between 20 to 25 years for 11 kV, 13 kV motor, 25 to 30 years for 6 kV motor, 6.6 kV motor, and between 30 to 35 years for 3.3 kV and 4.16 kV motor. So we need to ensure that the motors are operating with maximum winding temperature around 100 degrees Celsius, it could be 110. For every 10 degree rise up to 120 degree, motor life will reduce by 5 years. So when I say the motor, say 6 kV motor last 30 years, the assumption is the temperature, winding temperature is less than 100 degrees Celsius. If it is 110 degrees Celsius, so it will be 25 years. If it is 120 degrees Celsius, it will be 20 years. So every 10 degree rise, it reduces the life by 5 years. 120 is the limit. Beyond 120, it cannot be predicted. That is first. The cooling system is clean. The fan, exchangers, etc. is clean. poor cooling could create hotspots inside, and even if winding temperature indicating within limit, we cannot see the hotspot. We have to always factor another 10 degree increase by hotspot. Bearing lubrication is done as per vendor recommendation. Vibration is well within limit. If you maintain bearing, vibration will be good. Vibration not only accelerates bearing failure, but it also contribute to the loose wedges or something like that. Then it will initiate the stator failure also. So vibration measurement is done for very big machine, but nowadays for the smaller high voltage machine, it's not worth it. So vibration measurement, unless it is online, if you do vibration measurement once in 1 month, it doesn't make any sense. So what do? We rely on the operator. Operator do the daily round, and they are so experienced, they can hear the vibration is more. Their ear is more important than the actual vibration tool. If the vibration is more, something is wrong, obviously. But if the bearing lubrication is done as per vendor recommendation, and as I said, for slip bearing, if you replace the oil every 2 years, then there should be no vibration if the alignment, etc. is correct. And the standby motors, if we have standby in petrochemical industry, A, B motor, if the motor is standing there forever, it will deteriorate. Like motor is like any industrial equipment, like your car. If you don't drive the car will become bad. So motor must run. So if you have a standby motor, the motor must be swapped every 6 months. So 6 months this motor, 6 months another motor, 6 months this motor, 6 months another motor. And motors are fully serviced at the projected half-life. So fully serviced, we open the motor, clean up everything. So you take to the workshop or on the site. So basically, a 13 kV motor will easily last up to 25 years if you follow this condition and service at say 12-13 years. 6 kV motor will easily last 30 years if we follow this and service at 15 years. So it's very easy, no rocket science, and I have followed this, and I saw motors are lasting 25-30 years for 11 kV machine, 6 kV machine also 25-30 years, 3.3 kV machines, 4 kV machine easily last 30-35 years because I followed this. So another important thing I think is obvious, because if the motor is standby, the space heater must be on, otherwise the moisture will deteriorate this thing. The high voltage motor comes with space heaters. Once you then shoot the space heater is always on. So a lot of people say, okay, I buy spare motor for critical machine. The spare motor strategy should be based on above. A new motor, of course, it can fail, say infant mortality, but spare motor strategy should be purchased on the point just now I said. If you maintain like this, there's no point buying spare motor. Even if it's very, very critical machine, it's not worth it actually. Rather, one should find a good repair shop who can repair the motor within 1 month. That is much better. But if you must buy spare motor, then you rely on your tan delta result and the partial discharge result. So those data will tell you when to buy a spare motor. So most of the time I used to buy spare motor after 7 to 10 years, let us say, even for very critical machine. At 7 years, 10 years, because second turnaround normally you send the motor for service, so you can see the motor condition, then you think about buying spare motor. Or if my tan delta is showing increasing more than 3%, 4%, 5%, definitely going to buy spare motor. Partial discharge is a big subject. Of course, you need a specialist guideline, but there are some like say 10 kV machine. 10 kV machine partial discharge count say 5,000, 6,000 picocoulomb, it is bad. For 6 kV machine, 5,000, 10,000 picocoulomb is not so bad, something like that. So that is a specialist subject. Partial discharge, you should always go to the equipment you are using, they should interpret it. But with experience, you can come up with yourself some data point. I have some data points. If somebody interested, if I get a comment, I can have another session on the partial discharge bearing measurement also. So bearing maintenance, slightly more detailed one. But I summarize, and I can have another one about the motor repair. If you repair, what are the things to be seen actually? I can have another session. But I just wanted to summarize the preventive maintenance task. One should do always a monthly preventive maintenance just to check the winding and bearing temperature. If it is coming to DCS, then of course you can set some alarm yourself, or DCS can set some alarm. You can look at daily for critical machine. Otherwise, at least once a month, people should see the winding temperature and bearing temperature. And the vibration reading, of course, as I say, doesn't make much sense, but there is no harm taking a vibration reading with a handheld vibration reading unless the motor is installed with a online vibration measurement system. It's a minimum. It takes 5 minutes to do a monthly maintenance. 6 monthly PM, motors must be swapped if it is a standby motor, very important. For anti-friction bearing, it must be grease. Yeah. See, as I say, one good stroke between 1 to 2 grams. So you know how many grams you have to put. Suppose the motor has got a 200 gram initially, you should put 40-50 grams. So 40-50 strokes. That's very important. Over greasing is not good. And if the motor is TFC, so clean the fin. We can just take a brush and clean the fin from outside. Very simple. 6 monthly, basically swap the motor and do the greasing. 2 yearly PM, mainly for slip bearing. Self bath type, 2 yearly must be replace the oil. Very important. Okay. And as I say, like, if it is got an online partial measurement like iris coupler or something like this, the PD pulse magnitude, you can, as I say, I say in picocoulomb, but I think iris comes with a millivolt or volt. Basically, anything for 6 kV machine, if it is exceeding 0.25 volt, it is not good. And for 10 kV machine or 11 kV machine, if it is exceeding 0.5 volt, it is not good. So that is from my experience, that is the break point. So if you have 11 kV or 13 kV machine, it should be 0.5 volt maximum PD pulse magnitude. For 6 kV machine, 0.25. That should be break point. 10-12 years, basically half life of the machine. It will be good to do a offline test, like as I say, ABB leap test. If you can afford it, it is a bit costly, but otherwise you do a 10 delta test. That is good enough. And 15 years, even if you do a 10 delta test, leap test, that actually will tell you whether to send the motor to service or not. You can open to see the inspection. If you see a lot of dust and dirt and the tail delta is telling bad result, then you send the motor for servicing. If you don't do anything, send the motor for servicing at the half-life, which is 15 years. Then the motor will last 30 years. So that's all I have today. If you have comment, you can put it in the comment. I will try to see if there's a comment, I will try to reply. And if I see a lot of interest, I can have one discussion on what are the things to see in the motor repair. Thank you. Bye-bye. Ciao today.